Have you gone through the PPT last we shared?
Yeah, at least I went through the recording at least. So yeah.
Okay, great, no problem. So
Yeah,
we
I
are.
had a chance to look at the videos as well and the recording also.
So we are okay with mean median mode, right? The standard deviation and everything. Now let's start a kind of new step towards overall the machine learning part of it. So why solutioning is the problem here. But that, no problem. So what we are trying to do, we are trying to step into the actual data science solutioning. Now, what we do, we play around with data, right? As a scientist, we do research on data. We try to build up various, solution on basis of data for a business. That's the normal, thought process we carry, right? But we do build solution for various institutions, various organizations, and for various products as well. So products, basically there's a big difference between building a products and building solution for a company. Building solution for a company is basically well thought process of management, but building products is basically well thought process of research for a given market, for a given scenario, and so on and so forth. Could you understand the difference? Anybody ever worked on product development here? Or anybody who could understand what is product development and how is different from overall solutioning or project development? Anybody?
I think
Uh-huh.
product development is first understanding the business, and then we are not really doing any coding or building yet.
Right.
Maybe
So there is a market research, or we call it simple research, right? We do research. Let's say if you want to, let's say you want to build an electric car, which is much more efficient than Tesla. So what we'll do, you'll basically sit back on your chair, start thinking, how can I better beat Tesla in their most efficient, battery or charge release mechanism, their throughput, their fast charging with what all type of charging methodologies you can use, and so on and so forth. So that's we sit together, we do some research, we do some a thorough research in terms of where we are to target. So product is a kind of pre-preparation is much more important in product scenario, where we try to build the necessary aims for development. In this in other scenario, be it a service solution project, you get those requirements from somebody. You normally cultivate or you normally nourish somebody's vision and try to build solution for them. It can be CEO, CTOs of the world. It can be your partner, client of the world. It can be something like you are helping out some community. So the requirements come from somebody else. But for product, you conceive requirement within yourself. You think through that I can help the society in this way. So let's try to build such thing. So you collect some data, you build some research, right? So overall, as a solution architect, as a overall, data scientist, we build solutions sometimes proactively, sometimes reactively. That's the difference basically. And this is really, a kind of difference we should understand in typical product or a project or solution development. Similarly, in case of services, you want to build services, you normally try to do research for that. Like let's say if you want to start a air taxi service from New York to LA. So what we do, we normally sit together, try to understand who are these daily shuttles doing, because there are quite a few daily shuttles from New York to LA, New York to San Francisco, and so on and so forth. So how they work out, what type of flights, how many passengers on daily basis, how could we pip into it, how could we gain the profit, even helping others as well. So unless you help other, you couldn't basically grow after a certain point. So that's what they call business threshold and all those things, right? So there we sit together, we do research, we collect data. Now, as in data engineering or as in data scientist, we do data engineering, mining, solutioning, and we try to understand overall the data management, how to collect data, how to clean that data, because whenever you try to collect data, you might get some noise, you might get some data which is not relevant to your thought process. So what I do, I sit together, I try to clean it up, I try to remove the noise from it and try to align myself to the crux of the problem or to the aim of the solution I'm trying to do, and try to align data towards that aim. This is what we call business augmentation, business alignment, get in line with business, and so on and so forth. So you clean, you align the data, you prepare the data. Prepare the data in the sense you normalize the data so that you can get an efficient output with the data, because as a data scientist, we work with heavy data, a heavy volume of data. So we might need an efficient way to understand the data or get the result from the data as we are looking for. So we prepare the data and then we go to the solutioning. So solutioning is one of these parts. Overall, these can be 5 steps, 6 steps, 3 steps, 4 steps, depending upon the overall, designers and architects of the world, because they build these solutions, we help them out. If you join a startup, you normally start working on this line from startup. Like you start collecting the data also. If you work with startup, if you join any organization who is already had a data scientist practiced, so you join the team. You normally work with your team lead, reporting authorities, or the designers and the architect of the world who normally do this thing for you. You more concentrate on preparing or getting the data and preparing the solution. The cleaning is done by them. Even most of the preparation is done by them. Or you might get data aligned as per your thought process, prepare the data as per your thought process, and then build the solution. And that's how the overall process. So if somebody asks you in the interview, how are you going to prepare the data solution? You should, tell them about these steps, like collect, clean, align, prepare, and then work on the solution. That's the standard way of approach in a typical data scientist community. Now, again, these are the common practices. There could be 3 words, there could be 6 words, and so on and so forth. Okay, so you can think it through. You can build your own approach in terms of building data solutions. Again, we are not architect or designers, but we do help architects and designers. We do mentor them to build solutions. We are scientists. We are much more senior than architects, solution, project managers, and all those things. So we guide these guys in terms of how we build this solution, right? Any confusion so far? Have you understand how to express these steps in your word?
Yeah.
Yes.
Okay. Now, why am I bringing this thing right now? Because now hereforth, we are basically analyzing the term data in terms of how do we provide solution as a data scientist to the community. Now, solutioning is much more than just designing or architecting. Solutioning is helping somebody out, be it a business, be it a community, be it anybody for that matters. But you are building something to create some value, to create more efficiency in one way or the other, be it for a community, be it for a business, or be it for a particular group of people. This can also happen. So, like building a mass Land Rover, right? You're building these things, you can say, for humanity, but at the end of the day, there are 4 or 5 year reporting authorities. You're trying to satisfy their need in terms of giving the data scientist solution, and that's why the stakeholders are senior people, and they might be something like vertical L, horizontal head, and all those guys as well. So we closely work with these guys to build solution. Now here the most important part, as a data scientist, as an emerging domain, we don't limit ourselves in a list of requirements. Even if you try to build a product, well, you prioritize them, but still the thought process of building solution is continuously evolving. And that's the base. That's why we call ourselves scientists rather than designers, architect, or a project manager, senior manager, program manager, and all the bandwagons of different designations or roles and responsibility. So we call ourselves data scientists in some scenario where if you start working with something like startup, you might start working as an analyst, then you move to a designer, architect, even managing the solution, managing the construction of the solution, trying to be as a test manager, trying to be as a release manager, trying to build the solution, how it gets shaped up, and continuously evolve the solution. But otherwise, in normally 80% or more than 60% of cases, you join a team of data scientists where we have all the others to support you in terms of you normally work on understanding the data, trying to guide these people to collect, clean, and then you sit with them, get the data aligned, get the data prepared for the solution, and then start building solution on top of them. There's a bit of difference, but these verbos, these statements basically make ourselves to build the overall solution for the interested party. We normally refer them as a stakeholder. So stakeholder means whoever we are doing the solution for, right? Whoever we are working for, be it your reporting authority, be it your client, be it a community, or be it something like another scientific community for which you are building this solution. Okay? Any confusion so far?
No.
Oh, so, yeah.
Yeah, and for this, we use many database systems. So we might use something like MySQL, which we tried on. We might use something like Oracle, Sybase, big data, small data, this data, that data, and various database systems overall. But we don't do the programming. Even in a normal scenario, you have a database administrator and database development team to support you in this. So the basic nitty-gritty in this whole solutioning as far as database communication or database throughput goes, we just help them out how to do what to do, and then they will figure out how to do it. In the rare scenario, you might work on SQL queries, but that's not the normal case. Then we do analyze data. So we have analysts at our disposal in most of the time. They do data analysis. So even collecting, cleaning, and aligning are done by the data analyst team. These data analyst team, they closely work with business analysts and the other analysts of the world. They closely work with project manager to build this collect, clean, alignment in terms of all these data solutioning pre-preparation part. So we get the prepared data for our solutioning as the way we requested them, as the way we guide them, mentor them for. Now here the critical thinking becomes very important in terms of how do we build the solution. So your alignment, your thought process toward building the solutions need to be clear, critical, well aligned, well thought through. So that's why predominantly we call data scientists rather than data analyst, or rather than solution architect or designers, or any other label for that matter. So we are called data scientists because we mostly use our critical thinking, we mostly use our solutioning in terms of building the solution or get it built by all these other teams in the world, or supporting us in a given scenario. So that's why critical thinking is much more important in our scenario, and all these mathematical terminology, be it statistic, probability, and all those things, is going to help us out to discuss our solutioning with others. Right now, why we are basically trying to understand these mathematical verbos, because as a data scientist, maximum of our solution building or thought process or conceptualizing the solution involves mathematics. We try to teach machine, right? We try to automate machine learning. We try to make sure the machine start understanding itself. And that's what the machine learning is all about. Now we need to be very clear in terms of machine learning. In a given scenario, as a basis of computer science or a digital science, machine couldn't understand anything about on and off. And then we build this Boolean algebra so that the machine can act as a calculator for us. So what they do add in terms of binary, get them converted into normal, digital figures or the numbers, and then they'll show you those figures, the numbers, and the image. Even as a data scientist, I can clearly understand the vertical line 1 is just a picture. The 2, as you can see here, 2022, this 2 is also a figure. 0 is also a picture, right? Now, these are just some pixels arranged in a specific way. What world refers as a 1, 2, 0, 3, 4, whatnot, right? And they play around with these 10 digits from 0 to 9. These are 10 digits. This whole math partigram gets played around. Now we try to build these solutions for humans, but at the end of the day, at the bottom of it, the machines are working for you. So whenever you think through a solutions, we might need to go to a level where we try to understand this whole statistic probability in terms of Boolean algebra also. Right now is not the time, but please keep in mind, we might go to that granular level sometimes. More or less, we just happy in terms of sorting those things out in a normal digital mathematics way, using this 0 to 9 as in figures to represent our maths on day-to-day basis. But as a scientist, I need to understand the roots of the solutioning. I need to understand the roots how actually machine learns, right? And for that, there are some terminologies we use on day-to-day basis. In the data scientist community, we're going to understand that or start understanding that from today. And we might step by step learn machine learning. Machine learning is a progressive learning step because we need to first understand how machine performs, how their workflow is getting executed. Think of you build a robotic arm, you build some motors, you build some movements on the robotic arm. Now in that robotic arm, you have some stepper motors to move that arm within certain degrees of rotations, right? So you have a hands joint moved by 30 degree. Again, you have the finger joints move by 10, 20 and whatnot degrees you have already programmed to, let's say, lift a glass of water with the perfect stress points, pressure points and all those things. You calculate even those sensors at the tip of the fingers, try to get a grip on the glass. Again, the stepper motor at the joints basically gets starts with a few degree of movement step by step. Now why I'm trying to explain you these things, because all these motions which can be really looked at a hand as simple as a hand lifting a glass of water, but internally the programming gimmicks of it is a huge data communication between those motors, between the computer where the motors are attached or the motors are being commanded by, and step by step. So we might need to go to that level in terms of nitty-gritty to make sure we teach the machine, and the next step machines start learning by themselves. And we'll see how we basically get to that level. But first and foremost, how do you make machine works is the first step in machine learning. So how do you get the machine work for you? You have all these motors, you have all these different sensors to make the machine move, to make the machine work for us. And then we step into the machine learning. Now for all these gamut of ordering, gamut of having that data communication, we need to understand two terms specifically at this moment. One of them is what we call entropy, and the other is gain. Now we'll understand and basically discuss on these two terminology. And there are quite a few questions normally asked in the interview, in the job interview, about how do you think or how do you explain entropy or how do you explain gain? Because these are the basics for decision tree. We'll understand decision tree today, and then we'll keep understanding decision tree throughout the remaining sessions of the Python data science. Okay, but first and foremost, let's try to understand entropy and gain, and then we'll discuss it out. Now we are moving into the most serious, serious parts of the data science, or serious parts of the understanding how data scientists function on a thought process level or solutioning level to build them solution and to guide others as well. Okay, so let's start on entropy and gain in Python specifically. As Python is our basic development platform, well, the thought process in terms of what is entropy and what is gain doesn't change, but we are going to refer some solutioning, some programming tactics, how we basically understand entropy and gain in Python. That's why I normally mention there entropy and gain in Python. The data augmentation or cleaning or aligning of data is required for solution. We modify data in some or other way. We understood this, right? We already discussed this. Information gain calculates the reduction in entropy or surprise from transforming data set in some way. Now let's try to understand this statement. Information gain calculates the reduction in entropy. Now there are two words we might have not used earlier, or surprise from transforming data set in some way. Now entropy is what we call surprise or the unknowns. And information gain is whatever we want to know. So there's a know and there are unknowns. So we are trying to clear or trying to get the knowns from unknowns, and we try to remove unknowns step by step. Let's go in a bit depth and try to understand it more better. It is commonly used in construction of decision tree for training data sets. By evaluating the information gain for each variable and selecting the variable that maximize information gain, which in turn minimize the entropy. So the more you know the knowns, the rest will be the unknowns. So this is an evolutionary step to collect more of gain and less of entropy. This is how even human learns. If you look at a kid, the way kid learns, it try to learn step by step how to drink milk. First, we give them those bottles, right? And then you give them cup. The milk is the basic content. It doesn't differ that much. Well, in one you might give a plain milk, but now you have all those, Bonvita, Horlicks, and other additional supplements get added to them and let them drink the tea via cup, right? Now, first we normally give them the plastic mugs, those cups, right? So even if they, let them fall, or by mistake, if they, drop to the floor, they won't break every time. Now, why we do this thing? Because we are trying to avoid the risk. We are trying to reduce the risk. We are trying to make them understand you shouldn't lose the cup to the floor. So what we do, we try to basically guide them more to gain and less to entropy. Information gain can also be used to feature selection. So whenever you're selecting data, you try to understand the data in terms of gain and entropy by evaluating the gain of each variable in a context. Now, when I'm talking about the kid and the class, here I have two variables, but let's consider on these two major variables. There are kids who is performing a process of drinking a milk, and then there's a teacup or a milk cup. Because I'm trying to make the kid learn, we shouldn't drop the mug, right? So for that matter, what I do, I try normally evaluating what are the different outcomes to the given variables, what are the different probabilities on that variables which are at play here in this process, and how can I reduce the reduce the entropy and try to have more gain in alignment of the process of requirement. The requirement can be my personal, can be driven by my thought process or the work at hand. The requirement can be guided by others as well. In this slightly different usage, the calculation is referred to as a mutual information between the two random variables. Now, as we are basically depending on two variables, there could be many, but right now these are correlated in one way or the other, and their different states guide us on the levels of entropy and gain. Any confusion or anything you couldn't understand? I know it's a difficult topic. We might need to revise, and believe me, we will revise these things step by step in a way. But whatever I have just said, any confusion in those statements, anything which you couldn't understand?
Basically what you're trying to say is entropy is like an unknown thing, and once you learn more and more, the known thing is called as gain, right? Are
Right.
these statistical terms, this entropy and gain?
Let's call them mathematical term, because
Oh, mathematical.
mentioned in statistics as well as probability theories and various other places. And nowadays, as far as data scientist goes, these are really in what you can say mainstream of discussions. Means you might heard these terms in interviews, in the discussions, and so on and so forth. So we need to get habituated of on these words, right? As I told you, we normally get aligned ourselves with the trick of the trades, right? So these are the few words they use quite repeatedly. So that's why the thought process has to be very clear on these two. And you are correctly said, very rightly said, sir, in the few words. Gain is what we learn or keep learning, or what we have gained the understanding of. Entropy is the noise or which I haven't learned it yet. Very rightly said. Anyone else want to explain as well? See, this is a need of the hour, and unless and until you get your thoughts cleared, aligned around these terms, it's difficult to understand the other data scientist or the data scientist whoever working on many data solutioning project. Does that make sense?
Yeah.
So whenever you discuss something with in terms of solution, in terms of planning or cleaning the data, you might use these terms on a day-to-day basis whenever you start working as a data scientist. And as a scientist, we use this terminology quite often. Okay. So let's take a step further. Now let's try to understand how we use this terminology in terms of our day-to-day life, or in terms of how do you make sure we build these things as a decision-based thing, right? So let's try to understand. Let's say, okay, rather than milk and kid, here, I'm trying to use a solution given at towards data science website. It's really good and simple example. Now, decision tree is basically kind of activity diagram or a flow chart where we try to understand how the progression happens in a given solution. In this example, a decision tree can pick up on the fact that you should only eat cookie if certain criteria are met. And this is ultimate goal of the decision tree. We want to keep making decisions or different choice of decisions or splits until certain criteria are met. So here we are trying to decide if I should eat the cookie or not. Now, what are the decision points here, or what are the options do I have? I need to check out, should I eat or not? If I say, don't eat, then there's no problem. If I say I have to eat the cookie, then I need to understand, will it ruin my dinner, the calorie content, and all those other decision points. If yes, then don't eat. If no, then eat. So these are just a simple two-step process we have said here. In terms of kids and milk, do I have to make sure the kid will lose the cup on the floor? Yes, there's a probability. So what I need to do, I need to support the cup till the kid finishes the milk. But the kid has to drink the milk, right? Otherwise, how will get those nutrients in the morning or evening or afternoon, whatnot? So I need to set up a process to make sure whatever I want to achieve, I achieve it with the maximum gain. That's the aim of the decision tree. And well, the example of cookie is very basic, and we just have two decisions to be catered to, right? So here, this example is very basic and only two variables: allergy, ruining the dinner, and all those things. If I'm allergic to the peanuts, and if the cookie is of peanut cookie, then I'll not eat, because because I think I'm allergic to peanuts. If no, then I can eat the cookie. Well, will it ruin a dinner? Yes, no. If it's going to ruin your dinner, please don't eat. Eat the dinner, and then you can think of cookie and all those things. So these progressive decisioning keep happening in a given scenarios. But as a decision tree, I need to understand how to gain more, how to build information gain throughout the process with these decisions, of course. But if you have a data set with thousands of variables and columns, how do you decide which variable columns are the most efficient to split on? A popular way to solve this problem is entropy and information gain. Now, if you look at the size of the data and the decision of to be made by certain programs, so we need to use some formulas, we need to use some decision techniques to make sure we understand the gain and reduce the entropy. Now here, what we keep doing, we keep solving the issue incrementally, step by step, because we can easily distinguish between yes or no, right? And these decision tree, and that's why they call decision tree, because we just need to decide on or off, yes or no, 0 or 1. As simple as that. So we are at a ground level where we are trying to understand how the program will function for a given choice of these two. To get us started, we will use an information theory matrix called entropy. In data science, entropy is used a way to measure how mixed a colony is, and specifically entropy is used how the measure of disorder. Now there are two additional terms here, mixed column and measure of disorder. Let's try to understand the mixed column part of it. Now mixed column is if we take more variable to decide, then we might need to split the decision process to the second step. So what we do, we can decide between 0 and 1. Now, if I have added variable, I'll take another step and have this decision done by them again. So that's why I call it a mixed decision here. So I'm deciding twice rather than once. As a human, I might decide once for quite a few number of variables. But as a machine, I need to understand how step by step I do evolve. And this way I reduce the entropy or I reduce the disorders. Does that make sense to you?
Yes.
Yep.
I know it's an incremental learning. It's not like, I tell you and you learn, because I'm not a linguist, but I'm trying to guide you in terms of programmatic way, in terms of how we calculate the entropy in a given program. If I throw these, formulas to you, it's really difficult to understand. If you're a mathematician, then definitely yes. But if you're not a mathematician, then it's a bit of challenge of understanding this entropy and information gain. Again, these two are balancing terminology. That's why we normally teach them together. Entropy measures the impurity or uncertainty present in a data. That's a kind of flat statement, or the statement which you need to understand from your own knowns and unknowns. And the information gain is basically how much information at a particular feature or a variable gives us about the final outcome. So information gain is basically my decisive points. And we have these, formulas which are developed by great statisticians, and they are really well respected for them. Now, here we have a formula called entropy of set equal to negation of sigma of n from I to L, P of I, log of 2, and P of I. And these formulas are basically guide you in terms of the probabilistic value of an entropy. And the information gain, similarly, which is a negation of it, or which is another part of a ratio of it, basically given here. Okay, I don't want to take you to the formula level because we have already developed the programs for this. But in case if somebody wants to go into the depth, we can go into these formulas, and there are quite a few number of variables or videos available on the YouTube. Let me try to showcase one of the video to you so that we can understand in a better depth about this entropy and how the way we think about the performance of a data, or performance of a validity of a data doesn't always reflect as actual. So we normally apply this confusion matrix to make sure we validate these data points on the basis of certain matrix to make sure whatever we are learning, understanding is in line with the precision is in line with the recalls and all those things. So these data points, this confusion matrix gives us a clarity in terms of usability of the model, and that's how we normally calibrate these models on a confusion matrix. And these are all shared data. This is the data of 165 patients we just discussed about, where we have true actuals versus predicted, and then we had when we asked them, and then we actually tested them on the ground, and that's how they basically that's how they basically we validated those points along the line of the actual results versus assumed results, and that's the way we basically release or we basically reach to a decision where how precision is the how precision was the model, how these classification helps us out to build actual accuracy while applying this given model. Does that make any sense?
Yeah.
Yes.
We need to try it out practically. So as we discussed on these two different examples where we have 165 and then we have those 100 patients we discussed about in terms of actually how the two actual or two positive or two negatives, and those classification of these matrix, and give you exact ratio of the precision, the accuracy, and so on and so forth. So this terminology we do use whenever we normally try to categorize the model at a given point. Now let's try to understand why we do this and how these are going to help us in basically building the decision tree, right? Now, a decision tree is like a flowchart structure in which each internal node represents a test or an attribute. So we're going to decide on the decision node whether a flip of coin comes of heads or tails. Each branch represents an outcome of a test, or each leaf or node represents a class label. Decision taken after computing all attributes. So if I need to decide, I normally start with bifurcating them and then taking a step further and bifurcating them, and at the end I might reach a result, or I might basically come out with so many outcomes of these decisions. Okay, so rather than finality, I'm trying to understand the probability of outcome first, and then try to gain on the way of how things are being predicted one by one. A decision tree is that decision support tool uses a tree-like model of decision and their possible consequences, including chance, event outcomes, resource cost, and utility. Well, we can go on and on, but predominantly we normally go with two decision points at one time, and so on and so forth. It is a one way to display an algorithm that only contains conditional control statements. So this is a progressive thinking as far as how the probability will come in my way when I walk on this activity diagram or these event paths. That's how they basically tell you out. Okay, let's try to understand from a good video where we'll basically make sure we try to build our own. So in a typical decision tree or the learning of a decision tree, a tree can be learned, tree can be experienced by splitting the source set into subset based on an attribute value test. The process is repeated on each derived subset or a decision point in a recursive manner called recursive partitioning. So we are deviating or building those alternative paths, and that's what we call recursive partitioning. The recursion is complete when a subset at a node all has the same value or of a target variable, or when the splitting no longer adds value to the predictions. So when you achieve the last decision, you normally stop partitioning. The construction of a decision tree classifier does not require any domain knowledge because it's a small, it's a decision thought process, right? So you are choosing between one or the other, or one parameter or the other parameter, and therefore is appropriate for explanatory knowledge discovery. So we are discovering knowledge in a step-by-step decisive way. So that's why decision tree can handle high dimensional data as well, or where the probability are many to one and those kind of scenario. In general, decision tree classifier has a good accuracy. Decision tree induction is a typical inductive approach to learn knowledge on classification. Now here we are trying to basically classify each and every such decision in the one or the other, and so on and so forth. We keep walking till we'll reach a normal common end where the splitting no longer makes a sense, right? And this way we normally build a decision tree step by step. It's almost 10 o'clock, 10:30. So could we continue or should we stop here? Your choice. There are a couple of topics, within decision tree, which basically we'll try to learn how we implement these algorithm in a programmatic way or a numerical way, and then we'll take a step-by-step approach to basically implement decision tree in a given program or a Python programming way. Do you want me to stop here or should we, go ahead? Because there are lots of theoretical things we learned today. So you tell me.
We'll stop here. No worries.
I know. These are heavy things, and I'll release the recording. We'll publish this thing on YouTube as well, so it'll be help us, to all, and you can refer it whenever from your mobile and everything as well. Okay, chalo then. Thanks a lot for your time. You have a good night. Bye bye. Take care.
Okay. Thank you.
Bye bye.